Hello students, I am Sanjana Kavatigi, Assistant Professor, Department of Computer Science and Engineering, AITM, Belgavi. In the last video, we have started with module number 5, that is basic processing unit, and we've also studied the fundamental concept. In that, we have seen the single bus organization of the data path inside a processor. Okay, in this video, we shall study register transfers. Okay, as I've told in the last video, we shall see the operations like transfer a word, uh, operations that are sequence of operations that were used in executing a program. Okay, let me revise. First point is transfer a word of data from one processor register to another or to the ALU, and then perform an arithmetic or a logic operation and store the result in a processor register. Next is fetch the contents of a given memory location and load them into a processor register. The last point is store a word of data from a processor register into a given memory location. So these were the basic steps that were followed in sequence in executing uh, an instruction into a processor. So first we shall study register transfers. Register transfers. So instruction execution involves a sequence of steps in which data are transferred from one register to another. So for each register, two control signals are going to be used to place the contents of that register on the bus or to load the data on the bus into the register. There are two things happening here. One, understand clearly. So two control signals will be used. For one is to place the contents of the register, okay, the data that is stored in the register on the bus, that is one thing, or load the data that is there on the bus into the register. One is from register to bus, the next is from bus to register. Okay, so this is represented in the figure 7.2 from the textbook. Okay, so input and output gating for the registers. Okay, so the input and output of register Ri connected to the bus via switches is controlled by the signals Ri in and Ri out respectively. You can see the signals Ri in and Ri out. So okay, it is controlled by these two control signals. So when Ri in is set to 1, the data on the bus is loaded into Ri. Okay, so Ri if it is set to 1, Ri in if it is set to 1, then the data on the bus are loaded into Ri. Similarly, when Ri out is set to 1, the contents of the Ri are placed on the bus. Okay, so while Ri is equal to 0, the bus can be used for transferring data from other registers. Okay, if Ri in is set to 1, the data on the bus, the data on the bus are loaded into Ri. Similarly, if Ri out is set to 1, then the contents of Ri will be placed onto the bus. If Ri out is equal to 0, then at that time the bus can be used for transferring data from other registers. Okay, now let us see. Suppose that we wish to transfer the contents of register R1 to register R4. Okay, so how this can be done? It can be done using the following steps. Okay, first is enable the output of register R1 by setting R1 out equal to 1. Okay, so at this time we can place the contents of the R1 to the processor bus. I cannot directly transfer copy the data of R1 to R4. What I can do, I have to go through the bus. So in that case, what I have to do, R1 out, I should set to 1. At this point of time, the data that is present on the R1 can be transferred or it can be placed onto the processor bus. Next, also we should enable the input of register R4 by setting R4 in to 1. Okay, because R4 has to accept the data now. So R4 in has to be set to 1. This loads the data from the processor bus to the register R4. Okay, so using these two steps I can place the data from register R1 to register R4. So all the operations and data transfers within the processor takes place within time periods defined by the processor clock. So the control signals that govern a particular transfer are asserted at the start of the clock cycle. So in our example, it is R1 out as well as R4 in, which is set to which are set to 1. Okay. So the registers consist of edge triggered flip flops. Okay. What are flip flops? We'll be studying in AD subject. Okay. Hence, at the next active edge of the clock, the flip-flops are that constituting the R4 will load the data that is present at their inputs. Okay. At the same time, the control signal R1 out and R4 in will return to 0. Okay. So we will use this simple model of timing of data transfer for the rest of the chapter. Okay. So we'll be using the same denomination over here. However, we should point out that other schemes are also possible. Let us take one more example. For example, data transfers may use both the rising and falling edges of the clock. Okay. Also, when edge triggered flip flops are not used. Okay. So two or more clock signals may be needed to guarantee a proper transfer of data. So this is known as a multi-phase clocking, because two or more clock signals will be needed for the proper transfer of data. Okay, so that is known as multi-phase clocking. So an implementation for 1 bit of register Ri, that is shown in the figure 7.3 from the textbook as an example, which is showing the input and output gating for 1 register bit. Okay. So a 2 input multiplexer is used to select the data applied to the input of an edge triggered D flip flop. Okay. So when the control input RIN is equal to 1, the multiplexer selects the data on the bus, and this data will be loaded into the flip flop at the rising edge of the clock. So then when RIN is equal to 0, the multiplexer feeds back the value that is currently stored in the flip flop. Okay, at the point when RIN is equal to 0, multiplexer feeds back the data value that is currently stored in the flip flop. So next, the Q output of the flip flop is connected to the bus via a tri-stage gate. When Ri out is equal to 0, the gate's output is in the high impedance, which is nothing but electrically disconnected state. So this corresponds to the open circuit state of a switch. When Ri out is equal to 1, the gate drives the bus to 0 or 1 depending on the value of Q. Okay. So this is about the register transfers. Thank you for watching.